Chapter 8, Section 2, Problem Solving in Geometry with Proportions. Yesterday we talked about a couple of properties of proportions. Today we're going to talk about a couple more. If we have the proportion A over B equals C over D, then we can write it as A over C equals B over D. Notice what we've done here is we've taken the two numerators and when we've created a proportion with them, and we've taken the two denominators and we've created a ratio with them. And what happens is when we cross multiply, we're still multiplying the same two variables. If you look at the first one, A over B equals C over D, when we cross multiply, we would have A times D equals C times B. Now when we cross multiply, we still have A over D, or A times D equals B times C. So we get the same cross product. The second one says, if A over B equals C over D, then A plus B over B equals C plus D over D. What we've done here is we've taken the denominator and we've added it to each numerator. Notice that we didn't necessarily add the same thing to both sides, but on the A over B side, we added B to the numerator, and the C over D side, we added D to the numerator. So for each ratio, you're going to add the denominator to the numerator, and that would still give you an equivalent proportion. This first example asks us to tell whether the statement is true. We have S over 10 equals 15 over T. And then it says then S over T equals 3 over 2. What it looks like we've done here is we've taken the numerator S and we've left it in the numerator, but then we've taken the denominator of the other one and made it the denominator of this one. There is no property, and then where they got the 3 over 2 from is that they took 15 over 10, but then they simplified it. 15 over 10 is equivalent to 3 over 2. There's nothing that said we could just take a proportion and just switch the denominators. And if you look at the cross product of these, then it would be false. If you look at this next example, it says if 3 over x equals 5 over y, then 3 plus x over x equals 5 plus y over y. We just talked about that property, and this is in fact true because what we've done is we've added the denominator to both numerators in this proportion. This next example says in the diagram MQ over MN equals LQ over LP. Find the length of LQ. They've given us a proportion and we just need to plug in what information we have from the diagram. If you look at MQ would have a length of 21. If you look at MN, it has a length of 6. If you look at LQ, that would be the whole bottom side from L to Q. We do not know the length of that, so that would be our variable x, and then we do know that LP is 5. So I can set up this proportion like this. I've just plugged in what I knew. When I cross multiply here, I have 21 times 5, which is 105, equals 6x. I need to divide both sides by 6, and when I do that, I get 17.5 equals x. So the length LQ is 17.5. The geometric mean of two positive numbers a and b is the positive number x such that a over x equals x over b. If you solve this proportion for x, you would find that x equals the square root of a times b. So when I want to find the geometric mean of two numbers a and b, I just simply take the square root of their product. If they ask me to find the geometric mean between 35 and 175, so what I need to do is I need to take the square root of 35 times 175. 35 times 175 is 6,125, so I need to take the square root of that. This is not a perfect square, but you should write it in simplest form, which would be 35 square roots of 5. This next example says you are building a scale model of your uncle's fishing boat. The boat is 62 feet long and 23 feet wide. The model will be 14 inches long. How wide should it be? There are several different ways that I could set up this proportion, and there are several different correct ways. It all depends on kind of how you look at it. There are also several incorrect ways, so you have to be careful how you set up a proportion. I will show you one way. If you have a question over how you, or if you are setting up proportions correct, then I can kind of talk to you individually about it. But like I said, it kind of depends on the problem and how you see the problem. But there are wrong ways to set up proportions. I set it up as 62 over 23 equals 14 over x. Why I did this is 62 is the original length, 23 is the original width. So I've taken that first ratio that I wrote is the original boat, and it's 62 feet over 23 feet. Then what I've done is I've set it equal to a ratio of the model, which it tells me is 14 inches long. Because 62 was my length, the 14 needs to go on top just like the 62 is on top. And I do not know what the width should be, so it's going to be x and it's going to be on bottom because 23 was the width of the boat. X is going to be the width of the model. You could have flipped these upside down. You could have 23 over 62 equals 14 over x over 14. You could have also put the 14x over x first equals 62 over 23. Like I said, there are several different ways that you could write a correct proportion for this problem. Any way that you write your proportion, this next step should be the same for everyone. When you cross multiply, you get 62x equals 322. If you do not get 62x equals 322 when you set up your proportion, then you did not set it up correctly. Now I need to divide both sides by 62, which gives me x equals 5.2, and it would be inches because it's the length of the model, or the width of the model. Today's assignment is on page 468. It's numbers 10 through 28 even, and 31 through 34.